Hey, what's going on? This video is going to be the full knife build start to finish of a 228 layer Damascus 15N20 and 1084 Go Mai kitchen cleaver. The person that ordered this 10-inch Damascus chef knife wanted a cleaver to go with it, so we'll see if we can make a nice little buddy for it. We'll start with 19 layers of alternating 1084 and 15N20. This is my usual process of prepping the steel by grinding off all of the mill scale and then degreasing the surfaces with acetone. I'll stack it up and weld the corners, and then I'll give it a soak in some WD-40 before going into the forge. I've been doing this for quite a while, and as far as I understand it, the oil coats the layers of steel and then burns off in the forge, leaving behind a microfilm of carbon. That layer prevents oxygen from getting to the steel and allowing forge scale to build up between the layers before forge welding. This allows me to get away with not using any flux when I forge weld. If you're trying this method for forge welding, it's important that you don't move the billet around at all once you put it in the forge for that first heat. You can imagine how fragile that carbon layer is, and if you're flipping the billet over or moving it around, you'll most likely create cracks and allow oxygen in between the layers of your steel. So put it in the forge and don't touch it again until you're ready to set the welds. After 3 or 4 heats, when I'm certain that the welds are fully set, I like to grind the edges of the billet and remove any tack welds. It seems like I end up removing a lot less material doing it this way rather than waiting until the billet's fully drawn out. I got this billet drawn out to around 3/8 of an inch thick by 1.5 inches wide before cutting it into 4 pieces to restack, which gets me to 76 layers. I'll repeat the process of grinding all the surfaces and then cleaning them with acetone. I'll give it another soak in WD-40 and get it back in the forge. We'll do that whole process again, and the last time cutting the billet into 3 pieces to restack, and that will get us to a total of 228 layers. If you're looking for any of the tools and materials I use in my videos, you can find links to a lot of them in the video description or on my website, davidmoonforge.com, under the product links tab. Since this is my last stack for the billet, I'm going to press in a pattern with some ladder dies. With traditional ladder Damascus, you'd then grind off the ridges to get a flat billet, and that would give you a very bold tiger striping effect to your billet. In this case, I'm just going to press the billet flat, and it gives a more subtle wave-like pattern. This is the same process that I did on the previous Damascus chef's knife, and I want the pattern on this cleaver to pair well with it. Right about here, I'm realizing that I don't have enough steel to make the knife that I need to make. I can't just make another billet and forge weld them together because my layer count would be too high to match the other knife. I reached out to the customer and asked what he thought about a Go Mai layered construction, and luckily he was all for it. I drew out the billet the rest of the way, cut it in half, and added 2 layers of 15N20 around a 1084 core. Hopefully that'll give us enough steel to forge out the blade that we want. I guess technically this isn't Go Mai since there are 6 layers, but it's just because I didn't have as thick of 1084 flat stock as I wanted for the core, so I doubled up some 1/4 inch bars. I'll draw the billet out this time just enough to get the length that I need, and then I can actually start forging the blade. After grinding all the edges, it looks like we've got some good solid welds. I start by isolating the handle material in the press and then drawing out as much width as possible with some fullering dies. Once the blade is to a manageable thickness, I'll start refining the shape on the anvil. I like to use a cross peen and a straight peen hammer to work the transition between the handle and the blade. I went back and forth between the two quite a bit when forging this knife. This blade was a little too wide for me to get the fullerene dies all the way out to the spine and the cutting edge with the press, so I had to spend some time hand hammering down the perimeter to get an even thickness all the way across the blade. I ended up with kind of a cup shape to the blade that I had to fix on the anvil. I wanted to try to forge in a bit of a curve in the tip of the blade to get a slight flare near the end. That's what I'm doing on the horn of the anvil here. And also here, but you can't see what I'm hammering. Sorry about that. I would have refined the spine and the edge profile a bit more on the anvil, but I was already slightly under the height that I wanted, and I didn't want to lose any more width in the blade. I just decided I'd fix up the profile on the grinder instead. I'll stamp this blade with my maker's mark, and then this knife is for a 3.5 Marine that I served with, so it'll also get the Dark Horse stamp. That's the battalion logo for 3rd Battalion, 5th Marines. Now that I've got the forging and grinding done, I'm going to let the blade cool slowly overnight in the forge to anneal the steel. This will soften it to make drilling holes quite a bit easier. I was really struggling to get the blade to fit in the forge here, plus I was doing it at a funny angle to not block the camera, and I actually ended up burning the back of my hand on the tool rest I had pulled out there. Here's a look at the rough profile and a closer look at the stamps. I drilled out 6 holes for handle pins and the rest for weight reduction and to allow the epoxy to bond all the way through from one scale to the other. I like using this stepper drill bit rather than using a large drill bit and then chamfering the edges. I think this gives a much cleaner finish. It almost sort of rounds over the edge as opposed to creating like a 45 or a 30-degree chamfer. Here's a quick look at some shots of the knife before we get on to heat treat. Now we're going to move on to heat treating, sanding, and acid etching the blade. I'm going to run 3 normalization cycles to dissolve the carbides and refine the grain structure of the steel. Those cycles will be at 1650, 1500, and 1400 degrees Fahrenheit. There's kind of a cool look at the darker color of the core steel centered along the edge. I'll quench the blade at 1475 degrees Fahrenheit in Parks 50 quench oil, and I heat that quench oil to around 120 degrees before quenching. Now if you listen closely here, you can hear a loud ting during the quench, and I thought for sure I was going to find a huge crack in this blade once I pulled it out of the quench tank. You can even hear me grunt because I thought I just ruined a bunch of Damascus and forging work. Somehow there don't seem to be any cracks anywhere. I'm not really sure what exactly I heard during the quench, but there don't appear to be any problems with this blade. I let the knife cool to room temperature in a vise to make sure that it hardens perfectly straight. I tempered the blade for two 2-hour cycles at 425 degrees Fahrenheit. That should give me a hardness of around 60 Rockwell. I'm going to take this up to a 220 grit finish on the 2x72 and then polish it up a bit with a very fine surface conditioning belt loaded with black rouge. This is just so I can do a test etch and make sure that the core steel is well centered and that I haven't ground through any of my outer layers of Damascus. After grinding the blade, I washed it well in warm soapy water to remove all of the polishing compound and then degreased it with brake cleaner. Just before going into the acid, I rinsed the blade in hot water, but I don't touch the steel with anything else at this point. Not my fingers, not a brush, nothing but water. I let the blade soak in gator piss for around 10 minutes since this is just a test etch, and then I neutralized the acid with a mixture of baking soda and water. That's kind of a bummer. You can see some spots where I just barely ground through the Damascus, and you can see the inner layers of 15 and 20 peeking through. But the core layer of 1084 looks really well centered across the entire blade. I'm going to grind the bevels on a slack belt, which will give them a convex shape. This will keep more mass behind the edge and make the cutting edge more durable for heavy-duty tasks. If you're looking for any of the tools and materials I use in my videos, you can find links to most of them in the video description or on my website, davidmoonforge.com, under the product links tab. It felt like I was hand sanding this blade forever. I alternate directions for sanding between each grit so that I can be sure that I've removed all of the scratches left from the previous grit paper. At 400 grit, I switched from a steel backer to a cherry wood sanding stick. This has a slight amount of give and blends the finish better across the contours of the blade. I took the finish up to 600 grit and ended with long continuous passes to make sure I don't leave any J-hooks behind. Here's a look at the 600 grit finish. After sanding, I gave it a polish on the buffing wheel with pink rouge. I typically don't like using a buffing wheel on any part of the blade, but Gator Piss is a relatively new product for me, and that's what they recommend. I made sure to finish the inside of the hole for hanging the knife so that it'll show off the different layers of steel after the etch. I degreased the blade with brake cleaner again and then rinsed it under hot water before submerging it in the Gator Piss. You can see that the acid starts working immediately and you can already see the pattern coming through. I set a timer for 20 minutes and checked on the blade every few minutes during the etch. After a couple minutes, I noticed the pattern was a little funky near my maker's mark, so I pulled the blade out and brushed that area with a toothbrush before putting it back in the acid. After the full 20-minute soak, I pulled the blade out and neutralized it in a bath of baking soda water and then rinsed it with warm water. I blew the blade dry with an air compressor and then coated the entire blade with WD-40 to let it sit overnight and let the oxide set. There's a pretty cool look at the layers of Damascus, 15 and 20, and the core steel. The next morning I wiped off all of the WD-40 and then washed the whole blade in warm soapy water. I touched up any areas where the 15 and 20 looked a little yellow or dull with the sunshine cloth. You can see that once the oxides are set, they shouldn't rub off at all when you wipe the blade. You don't see any black residue on the paper towel. Now I'll apply a food-safe blade wax and melt it with a heat gun to make sure it flows into any micro valleys in the Damascus. Here's a look at the final pattern. I think I'm still undecided on whether or not I like gator piss. I feel like you get really good contrast and the process is pretty simple, but you don't really get any depth to the etch. One of the things I like about my process with ferric chloride and coffee is that I can etch the blade and let the oxide set, and then lightly sand the high points of 15 and 20 with 2500 grit sandpaper. Because of the depth in the ferric chloride etch, sanding with high grit paper doesn't really affect the dark oxide layer in the valleys of the pattern. This is just a personal preference, but somehow it feels like there's something more authentic about the look of a Damascus pattern that was etched in ferric chloride. I think I'll likely find certain use cases for gator piss, but for now I think I prefer the look and the deeper etch I get with ferric chloride and coffee. Alright, let's get a handle on this thing. This handle is made from OD green linen micarta scales and black G10 liners. It'll have 6 3mm stainless steel pins. I clean up the ends and round over the edges so I can get them into the handle material a little easier. Before attaching the scales to the knife, I like to finish the fronts of the scales up to 600 grit and then polish them on a buffing wheel with pink rouge. Here's a look at it all polished up. I clean every surface with acetone and then blow it off with the air compressor to make sure I don't have any little lint or dust particles hanging around. I'm using Total Boat medium epoxy and I'll add in some black color pigment. You can find links to both of those products and lots of the other tools and materials I use in my videos in the video description or on my website davidmoonforge.com under the product links tab. Dyeing your epoxy really helps give some crisp lines along the junction of the tang and the handle scales. You just have to really make sure you've got a good color match between the epoxy and the liners. I'll clamp this up and let it cure overnight. I like to cut the excess off the handle pins with a hacksaw to prevent the epoxy around the pins from overheating. If you hit it with an angle grinder or you grind them down on the 2x72, they can get pretty hot and affect the cure of the epoxy. I recently changed my bandsaw blade and it cuts so much better. I don't know why I always wait so long to swap out the blades. They're expensive, but they're not really that expensive, and any kind of dull blades or tools have to be one of the most common causes of injuries in the shop. I'll profile the handle on the 2x72 and take it up to 220 grit before moving on to hand sanding. This rubber contact wheel works really well for smoothing out any rough edges or corners. It's got some give to it, so it does a good job of knocking down any high spots and working around the contours of the handle. This area right up where the handle scales end is one of the most important parts to make sure you don't have any sharp edges. A lot of people like to creep their hand up overlapping this part of the handle to give them better control of the knife for certain tasks, so you really need to make sure it's comfortable in the hand. After hand sanding up to 600 grit, I polished the handle on a buffing wheel with pink rouge. Here's a look at the handle before applying any finish. A finish isn't really necessary with micarta, but I find that Odie's oil helps keep the handle looking polished a little longer. Generally with unfinished micarta, it starts to look a little cloudy or dull pretty quickly with use. Odie's oil just seems to give it a little more sheen and keep it looking like new a little longer than without. I use ultra sharp diamond stones for sharpening, and I also use these angle guides by Etch. They come in a pack with all different angles, and you just attach whichever angle guide you want when sharpening. I think they work great for helping you maintain a consistent angle when sharpening, and especially when you're trying to establish a new secondary bevel. I progressed through a 300 grit, 1200 grit, and 3000 grit stone, and then moved on to a double-sided leather strop. I've got 5 micron diamond paste on one side and 3.5 micron diamond paste on the other side. After removing the tape from sharpening, I'm just going over the blade one more time with a sunshine cloth to polish up any rough spots in the Damascus. Lastly, I'll apply a food-safe blade wax and melt it with a heat gun. This allows the wax to seep into all of the micro valleys of the Damascus and help protect the oxides and the steel from forming any rust. Here's a look at the finished knife. Thanks for watching.